What's going on, all you amazingly beautiful people? So check this out. We are going to continue this binge watch series of learning organic chemistry because it doesn't have to be challenging. It doesn't matter if you ever have to take this class ever in your life. We're going to make this fun and exciting going through here so you can learn this. So last time we talked about, remember, think about these atoms. It's this game we're playing. Taking these atoms, thinking of them as they're a box. We can look at the periodic table and figure out the numbers. So if we look up here at the top, we've got carbon with 4 dots or 4 electrons. Hydrogens each have 1. And then this Br, which is bromine, has a total of 7. And so we talked about how we could basically think about carbon is always going to be typically in the middle when we're doing these initial structures. We're clicking them together like Legos. We put single electrons together. So the most logical way of doing that is carbon has 4 spots to click together. Each hydrogen has 1, bromine has 1, so kind of the numbers match up. So we've got our structure number 2 right there. So I wanted to show you those right there where, just to recap, where we could build molecules. Now, why is this so important? So these are Lewis structures, and what you can see is every single line. I'm going to draw this on here as well. We talked about this before, the fact that when we look at this, we don't draw all the dots because they take up way too much space. But if we were going to draw this over here, we draw lines instead of the 2 electrons. And then sometimes we'll leave all the dots on these atoms called lone pairs, but that would be the structure right there. Why am I spending so much time on here? Because once you understand Lewis structures the way that I've done them, which is ridiculously simple, I'm going to show you how this translates very seamlessly into doing reactions, which is by far the most important thing in organic chemistry, is forming and breaking bonds to carbon. Okay, I'm going to repeat that again. Forming and breaking bonds to carbon is the most important thing that you are going to wind up seeing in organic chemistry. And even if you're never going to take it again, it's the most important thing in terms of this game that we're playing here. So give me a sec to get this. So what we've talked about here is what we're going to find out is we're going to introduce another thing. So we can see this game kind of has these little things on it. We have these boxes with dots. We can click them together. We've got these lines. We're going to introduce something right here, which is arrows, meaning that if we have 2 dots, we can take those 2 dots and we're going to represent and show somebody that if we want to take those 2 dots and we want to move them, we want to connect them into something, we want to form a new bond to carbon and break a bond, we're going to take those 2 electrons, we're going to draw an arrow and show them going somewhere. Okay, so we have boxes, we have dots, and we have arrows in letters of the alphabet. All of us know what these are. So there isn't a single person on here who can tell me, Jay, I don't understand organic chemistry. You understand organic chemistry because you understand boxes, dots, and arrows. Okay, so I'm not buying it. I tell all my students, I don't believe them when they tell me that they don't understand this class because I've never met anybody that cannot do this class. Everybody can do this. Okay, even if you don't have to. We're going to make it fun. So we're going to scroll here to this one. Now, what is this all about? What this is I'm going to show you, if you look at this, we've got the structure on the right, which I guess in your case, if the video is flipped, is on the right, is our Lewis dot structure with our carbon, our 2 electrons, our bonds, our bromine, that. And then I've got this other molecule over here, which is iodine on the periodic table. But if you were to look at the periodic table, that iodine has 7 electrons around it, but in this case, I have 8. So when you start going through organic chemistry, you're going to find out some atoms are charged, some are not, and the difference is the number of electrons or dots around the box. So we can think about this way: if iodine wants 7, or if it has 7 and it's neutral, no charge, if we add an electron, each electron is negatively charged, so therefore we've added a negative without adding a positive, so therefore the overall molecule is negatively charged. So just to kind of give you a cap there. Now, how does this work? We're going to play a game called, we're going to form a new bond to carbon, okay? We can only have 4 bonds at any given time. And each bond, remember, is 2 electrons. So if we look at that, we already have 4 bonds around carbon. So if we want to put a new one on there, we have to get rid of one, okay? Now, if we look at that, we've got 4 options, right? We have 3 hydrogens, 1 bromine. Which one are we going to choose? We typically choose the weakest bond. Which one's the weakest bond? It's the one that usually is going to have a difference in electronegativity between the 2 atoms. We're not going to get into that on this thing. What I want to show you initially is how do we form and break bonds in a very simple way that is going to be much easier than the way that you're probably going to be taught in your class, okay? No disrespect to any professors. It's not about the way that they teach or not any of that. It's just the fact I want to show you a simple way of doing this. So this is how this works. In organic chemistry, everything revolves around 2 electrons, 2 dots, and we are going to draw an arrow to represent that. So if we were going to form a bond between these, what we want to do is come in here and we can use any 2 sets of these electrons, this, or this, to basically form a bond. So the way that we represent this, the way that we're going to form a new bond is we're going to take these 2 electrons, I'm just going to pick these, and I'm going to take those and I'm going to show somebody that what I want to do is I want to plug them into this box. Now, I'm not going to plug them into the corner. I'm just putting it somewhere where there's not something already. But imagine this is a plug. I'm literally going to plug them into the carbon, But in order to do that, I have to unplug something. Now, it makes sense kind of like in the wall, right? If I have an outlet over here, if you want to plug something in the same outlet, you have to unplug that one and plug it in. It's kind of like here in organic chemistry. We don't have to unplug something before we plug it in, but we do have to plug and unplug at the same time. So if I plug the iodine in, then I'm going to have to unplug, in this case, the bromine. But you'll notice when something's plugged in versus when it's not plugged in, the dots are different. When something's unplugged, I don't have it. I was going to show you my charger, but when it's unplugged, they kind of fall back on the atom. But when it's plugged in, they twist out so you can react. So if we were going to do this, I'm actually going to move this down here, and I can't see my camera, so I'm hoping that it's not going to be on top of my face. But we're going to take the iodine, we're going to plug it in. But watch this. What we're also going to do is we're going to unplug it over here, and we're going to draw an arrow. So what do these arrows mean? It means I'm going to take these two dots, and I'm going to plug it into the carbon, and I'm going to unplug these two dots, and I'm going to dump them on the bromine. It doesn't matter where your arrow is on this. You can draw it anywhere. You just want to let the person know that it's going to go to the arrow. So how would that look if we drew that out? So what would happen here is I'm going to grab this. I'm going to bring this over here. I'm going to erase this arrow because we don't need this. So what happens? Watch this. I'm going to try to do this visually. Sometimes this works. Sometimes this doesn't, depending. But I'm going to grab this. So watch this. I'm going to unplug the bromine, okay? The electrons go with it, remember, because what's going on is when I plug something in, it brings all the electrons. So I'm going to unplug this, and then all I'm going to do is I'm just going to rearrange these because we don't usually have them out like that. When they're not in a bond, they just sit on there. So now that box is coming off, but you're going to notice here that that bromine now has an extra electron on it. Instead of 7, it's got 8, so now that's negatively charged. But what I'm going to be able to do now is bring the iodine in over here, and I'm going to have to take one of these electrons, and I'm going to skadoosh that down like that. So now that forms a bond over there. So you can see this is literally the heart and soul of organic chemistry. Taking two dots, plugging it in, taking two dots, unplugging it. And you'll see that the group that comes in brings the electrons for the bond or the line, and the one that falls off takes them with it. Now, some of you might be saying, Jay, like, because I actually had a graduate student one time when I did stuff like this. Like, they actually told me, they left a comment like, this is way too easy. This is stupid. I'm not going to follow you anymore. So if any of you are thinking about the fact that this is way too easy, then you're on the right track because it is actually easy. Organic chemistry does not have to be difficult. It can be fun. It can be a little bit of game. But in this case, this is literally all that's happening. So when you're doing reactions, when you first get in there, you're literally going to plug it in and you are going to unplug it, and it all revolves around 2 electrons. Simple, right? So simple. I always tell my students, this is not brain surgery. This is not rocket science. This is organic chemistry. It's really not that bad. It's a puzzle. It's a game. It's rearranging. When you look at, when you look at this, you've got boxes and dots and arrows. Like, it is not intimidating at all. So cool. So I hope you all enjoyed this. I did. I love getting to simplify this to help anybody understand this. Love getting on here with all of you. And until next time, I hope you all have a good one.